We saw in the last video that pressure in gases is caused by gas particles colliding with the walls of the container, and that we can increase the pressure by increasing the temperature, increasing the number of particles, or decreasing the volume. This last rule means that pressure and volume are inversely related. So as one goes up, the other goes down. This means that for a given amount of gas at a constant temperature, the pressure times the volume will always be a constant value, which is how we get our PV equals constant equation. For example, if we increase the volume, then the pressure would decrease. So when multiplied together, they'd still give the same value. Regardless of why this works though, all we need to be able to do is use it in calculations. So let's give it a go and try a couple of examples. An unknown gas occupies a volume of 1.5 meters cubed at a pressure of 100 pascals. Calculate the pressure exerted by the gas if it's compressed to a volume of 0.3 meters cubed. Assume that the temperature and mass of the gas stay the same. So with questions like this, it's helpful to write out what we have. Effectively, we've got 1.5 meters cubed of a gas with a pressure of 100 pascals, and then 0.3 meters cubed of gas with an unknown pressure, which is what we're trying to find. So if we take our equation, PV equals constant, we can figure out the constant for the first gas sample by taking the pressure of 100 pascals and multiplying it by the volume of 1.5 meters cubed, which gives us a constant of 150. Then looking at our other gas sample, we know that its pressure times its volume must also equal 150. So to find the pressure, we can just plug in the 0.3 and then rearrange by dividing both sides by 0.3, which gives us 500 pascals. So we know that this new container must be at a pressure of 500 pascals. Now, there is another way of doing this that some people prefer. Because the constant is the same for both containers, instead of actually figuring out the constant, we can just say that the pressure times the volume in the first container equals the pressure times the volume in the second container. And to avoid getting the numbers confused, we normally say that P1 times V1 equals P2 times V2. So 100 times 1.5 equals something times 0.3, which we can rearrange to get 500 pascals, just like we got before. Let's try one more. To prepare for a dive, 1800 litres of air from the atmosphere is compressed into a 12-litre gas cylinder. Calculate the pressure of the air in the cylinder. Assume that the temperature remains constant and that atmospheric pressure is 101 kilopascals. In this question, it's a bit more difficult to see which values we're meant to use where. We're basically taking a volume of 1800 litres of atmospheric air and compressing it into the much smaller volume of 12 litres at an unknown pressure. The key thing to notice though is that atmospheric air will have a pressure of 101 kilopascals. So if we take the equation we just mentioned, all we have to do is substitute in 101 times 1800, which will equal something times 12. Then we just divide both sides by 12, and that'll give us a pressure of 15,150. And importantly, that will be in the units of kilopascals, as we used kilopascals for the units of our atmospheric gas.